Hello students. So now we shall see the important part of this photochemistry of carbonyl compounds, that is a very important named reaction. It is called as Paterno-Buchi reaction. So carbonyl compounds on irradiation in presence of olefin sealed oxyteins. So this photocycloaddition is generally known as Paterno-Buchi reaction. So reaction in this case of Paterno-Buchi happens between a ketone and alkene reacts with each other in the presence of a light and forms an oxytane. So addition is usually performed by irradiation with light, and it involves excited state of carbonyl compounds rather than that of olefin. So light energy needed for N to pi star transition is able to initiate the reaction in simple carbonyl compounds, while for some conjugated ketones it becomes difficult to distinguish between N pi star and pi pi star transitions. So it clearly shows that the reaction happens between ketone and alkene, and ketone will be in the excited state, and that is reaction happens between excited state of ketone and ground state of alkene. So here you can have taken example of a benzophenone and isobutene. It reacts with each other in presence of light to forms oxytane. So we have got two products, one is major 90% and another minor 10%. So both are oxytane, and reaction proceeds in these following two steps. The first step is excited carbonyl compound in triplet state add through its oxygen to the olefin and form two diradicals. So here benzophenone, so which absorbs light and it forms an excited singlet state. So in the excited singlet state, the spin which is that is in the case of benzophenone are in opposite direction. So in carbon you can see that is showing upward arrow mark, and in place of oxygen, in place of carbon it is upward arrow mark, and in place of oxygen it is downward arrow mark. From this excited singlet state it converts into the triplet state by intersystem crossing, that is spin inversion takes place. So now both carbon and oxygen both have an upward arrow mark, that is spin are both in same direction. So in case of carbonyl compound, in case of singlet state, spin are in opposite direction, but in case of triplet state, spin are in same direction. This triplet state gives rise to an oxytane. So this triplet state and reacts with a ground state of alkene and gives rise to a intermediate product where both the carbons will have a spin of same direction. So this gives rise to an oxytane. So now this oxytane now undergoes in the second step, spin inversion takes place and second bond is formed. So as you can see, so here it gives rise to, so when this triplet state of benzophenone and this ground state of ground singlet state of alkene reacts, it gives rise to two types of products. One is major, another one is minor. These undergo spin inversion. So the first product which has formed, we have shown one horizontal and the below vertical arrow mark, that is one product, and this is the other product. These products in the second step undergo spin inversion. So here you can see the first product which is formed, C6H5 twice, C single bond O, CCS3. So this is the one product which is formed in the first step. So this undergoes spin inversion at the carbon, at both the carbon atoms, and now this forms an oxytane which is the major product. The second product which is formed in the first step, that is C6H5 twice, C single bond O, CS2, CS3. So this is both, again in this case also both carbon atoms are having a same direction of spin. So these carbon atoms also undergo spin inversion and gives rise to a 10% a minor product. This is also another oxytocin. So right. So this is how. So this Paterno-Buchi reaction, which we call it as a photocyclic addition reaction, which happens between a ketone in an excited triplet state and alkene in a singlet ground state, reacts each other in presence of light to form an oxytocin.